morning, kids. Good morning. And it is morning. It's 5:20. That's not bad. Okay, kids, a couple things I want to make sure you talk about. One is where you can find all this stuff. I've now, oh shoot, I was going to upload this. Anyway, if I refresh, here, let me just go. If you go to NK Infinity, so check out, it's really simple, NK Infinity, there it is. Go over here to New York State Teachers, click on Review. I've updated the site a little bit last night, and you click on Final Week. That's what we're doing right now. That's today. I'm working on Final Week number 2. I'm definitely going to have a number 3. I just don't know if I'm certain I won't have time for 4, but if I do make a 4th document, I'll try to at least post it. But I'm not sure I can get the answers to you, okay, because that's going to be a tough one. All right, but this one's what we're working on right now. There's the one for document 1. That's the first thing I want to make sure you all understand. The second thing I want to make sure you understand, or that I talk with you about, is, what am I doing? That I need sleep. And that is that in the past, I've been able to record the videos the day of the test. At least I thought I could. I'm pretty sure I could. But now New York State has restricted that, and I'm not going to be able to post the final test until June 30th. I don't know why they're making you wait so long, but June 30th is the first day that I'm going to be able to record the things. So while I'm going to record them, I'm just going to leave them on my computer at home, and on June 30th, I will upload them. So I'll have links to all of this stuff on my website, but well, I'll have spaces for links on my website, but there won't be any links, and I'm not going to be able to post the videos or do anything. Don't ask me about any questions. I can't answer them. I'm not allowed to answer any questions. I'm not allowed to do anything of that. I wish I could. I'm also apologizing because I haven't been able to answer a lot of your questions because, quite frankly, I'm really busy. So, with all that done, let's get started on day 2. Even though it says day 21, it's really day 2 of the last week. All right. Read the question. Actually, you should have already started these questions. This is the 43rd and 45th terms in the sequence are 72 and 32. So it's coming down, 72 and 32. So it's either an arithmetic or a geometric sequence. Now, if it's arithmetic, I'm going to add something to get to here, and I'm going to add something to here. Now, it should be pretty obvious that it's going to be something negative because I have to take 72. Now, what am I going to add? I'm going to add x. I don't know what it is, but I'm going to add x. So if I add 2 x's, it should equal 32. Subtract 72, I get 2x equals negative 40. So x equals negative 20. Now that's what I'm adding, right? So if I take 72 and I add a negative 20, I arrive at 52. So 52 can in fact be the answer. Notice that I said which can't be. All right, so that's part 1. I'm not sure about the rest of it. So let's check the next one out. Let's say I want a geometric sequence. Well, geometric sequence means that I got to go from here to here and here to here by multiplying by something. Anybody want to guess what we're going to multiply by? Yeah, you guessed it, x. So we're going to take 72. We're going to multiply by x. We're going to multiply by x, and we're going to have it equal 32. Now to solve, you divide by 72. So you get x squared is equal to 32 over 72. Now, that's going to reduce nicely. 32 divided by 72, 4/9. So x squared is equal to 4/9. So, in order to find x, you take the square root of both sides. And when you take the square root, you put a plus or minus, which is really equal to plus or minus 2/3. So if I take 72 and I multiply by 2/3, I get 48. If I multiply by negative 2/3, I get negative 48. So there's the answer. A recursive formula in the sequence. So how do we go from 48 to 12 to 6 to 3? Aren't we just going in half every time? So how many of these have a half? These two have halves in them. Do you see that? A half, let me highlight it. Got a half here, and I got a half here. These have 2s. That would be like if I was going up by a factor of 2. I'm not. So none of these make sense. Then it said that it's recursive, right? Well, this is not a recursive formula. This is not a recursive formula. So here's the right answer. Choice 1. Now, Part B, this part says which is the geometric formula. This, if I ask for the geometric formula that would generate that sequence, is the right answer. So choice 2 would be the geometric sequence. A little known fact about Mix Dixon, she's an avid dominoes artist. In her latest creation, she had a board placed in such a way that it knocked down 38 dominoes, which in turn knocked down a row behind it, which had 40 dominoes, which knocked the row behind it, had 42 dominoes, etc., etc., etc. The pyramid of dominoes had 72 rows. What is the total number of dominoes in her piece? I should have said this part of the piece. Anyway, so the first row had 32, then it went to 40, then it went to 42. I think you can see that this is an arithmetic sequence and we're adding 2 every time. Now, because I want the total number, that you should recognize as a summation. How many rows are there? There are 72. So n equals 1 to 72 of... Now I'm going to create the arithmetic sequence formula. It's on your formula sheet. Remember, it goes a sub 1 plus n minus 1 times the common difference. Well, a sub 1 is 30, not 32. No. This should be 38. I don't know how I put 32 here. Now it looks like we're adding 2. 38 plus n minus 1 times 2. 2 being the common difference. All right, now I just got to go over the old Taschenrechner and get this baby typed in. Remember, it's found right here. See where I'm pointing? This little weird symbol next to the 9. We're going to click on that. And we're going to click on the summation. And we've got n1. I always go to the top. 72 rows. And then I type this in. Don't mess with those parentheses. Don't use those parentheses. Those parentheses just stay there. Don't touch them. Everything else has to be inside of those parentheses. So 38 plus n minus 1 times 2. Oops. I don't know what happened to my parentheses. See how I got weird parentheses there? That's a problem. All right, that's better. Woo, that would have been a problem. Here we go, 7,848. There it is. What are the transformations that took place to go from here to here? So it went from 1/3 to 3. So that's a dilation of 3. So this can't be the right answer. It went from no negative to a negative, so that's a reflection, but it's a reflection in the x-axis. It has nothing to do with the y-axis. And we're going to move, because that's inside the parentheses, we're going to move left 4. All right, kiddies, here we go. Cotangent squared 23 plus 1 equals cosecant squared of some angle. Well, this is one of those ones where you just have to know. This is one of those ones where you just have to know the formula. And the formula says cotangent squared theta plus 1 is equal to cosecant squared theta. Well, what do you notice? Same angle. Now, if you type that in your calculator, you find out they're equal. The other one you got to remember that's weird like this is tangent squared theta plus 1 is equal to secant squared theta. What is the period? Now remember, period is defined as the time it takes for one full cycle. So I'm going to highlight that in green. It's going to start here, and it's going to end here. So that's one full cycle. And I know that's hard to read, but that's done in pi. Oh, right, the equation for this, Grafton. Okay. All right, so the first thing you got to start, anytime you're going to go off an equation, is the midline. We got to find the midline. So the max is 2, and the min is -4. That's a difference of 6. So I got to go up 3 to get the midline, and it should be obvious. That looks like the midline right there. So I know at the end of this thing I'm going to have a -1, because see how it's going through -1? Y equals. Now, because it started down here at a min, I know it's a cosine curve. Because it started down at a min, I know it's negative. Because the amplitude is 3, I know this has a 3. So the only thing left to figure out is how many full sine curves there are in 2 pi. Well, here's 2 pi. So how many full sine curves are there in 2 pi? There's 1, there's 2, and there's the equation of that function. What is the value of x if this is 30 degrees? Now remember, see, notice it's a unit circle. So x is really just the cosine of 30 degrees. And then y would be the sine of 30 degrees. Do you all know that the cosine of 30 degrees is the square root of 3 over 2? If I wanted sine, this would be sine. And this would be tangent. And this would be nothing because it's for 45 degrees. The most real blah, 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 blah. This one right here, if you look through this problem, hope you look through this problem, it's looking for the max and the min height of this thing. Well, remember, max is, the formula for max is C plus A, where C is the midline, A is the amplitude. So this is C, this is A. Not the negative, I don't care about the negative. So C plus A is 240 plus 40, which is equal to 280. The min is defined as C minus min, C minus A, or 240 minus 40, which is 200. So 200 to 280. Oh yeah, this problem is awful. This was like number 24 in either August or January this last year. No. This was the first exam. Number 24 on June 2016 was just like this problem. Really, really bad question. So let's talk about it. Let's see if you can figure this out. You've got to walk yourself through this one, and you have to really understand trig to get this one right. The movement of current through the Skinner cyclonic doohickey, okay, I gave up, man. I had no idea what I was talking about, can be modeled by the cosine function. So that's why these are all cosine. It has a maximum current of 240. Notice C plus A is going to be 240. So that's all of these. So this really has nothing to do with the problem. And there are 12 complete cycles of current passing every second. So 12 cycles in 1 second. So what's the period then? Well, if I do 12 cycles in 1 second, doesn't it take 1/12 of a second to finish 1 cycle? Or in other words, the period is equal to 1/12. Well, the formula for period is 2 pi over b. So if I wanted to solve for b, and the only thing I got left to find, this is the same, 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 the same. The only thing that's different is b. So really my only goal is to find out what b is. And that's what I'm going to find out right here by cross multiplying. If I cross multiply, I find b is 24 pi. Events J and K are known to be independent. As soon as I see this, I know 3 things. I know the probability of J is equal to the probability of J given K. I know the probability of K is equal to the probability of K given J. And I know the probability of J and K is equal to the probability of J times the probability of K. I know all of those things. All right. The next thing I was given was this beast right here, and that's the most important thing on this problem, is the probability of J or K. As soon as you see that, you need to write the formula for OR. Probability of J or K is equal to the probability of J plus the probability of K minus probability of J Oops. That'll come later. And k. So if you notice, the only thing I actually gave you was this. The only thing I gave you out of this whole formula was that. The only number I was giving you was that. Like, I gave you this number right here, but it's not in this problem. So what I'm trying to say is, if you didn't realize that independent events gave you these three things, this problem is virtually impossible. So you got to know that independence gives you all of these things. So why does that help out? Well, that helps out now because this is really just the probability of j. So the probability of j is 0.62. Plus the probability of k, which is the thing I was given, was 0.43. Minus, now what in the heck am I going to do with this? This is like probability of j and k. Well, wait a second. I've got something for that. It's right here. The probability of j and k is equal to the probability of j times the probability of k. So really all I got to do is multiply these two things. 0.62 times 0.43. That is virtually impossible if you do not write this information down. Now I just come over to my calculator and I go 0.62 plus 0.43 minus 0.62 times 0.43. Type in that. They're all just numbers. There it is, 7843. All right, I actually got to change the tip on my electronic pencil because it's about to start scratching my thing. So I'll be back. Well, it's a good thing this year is almost over because I'm on my last tip. It's got a little white thing at the end. Weird. Anyway, the number of complaints about politics on social media has increased by 7.5% over the previous year. If this continues over the next month, which expression can be used to approximate the monthly percent increase in subscribers? All right, kids, there's two answers that actually could work on this problem. See, what it is it's 1 plus 0.075 to the, and I should have said that m represents what, the number of months or whatever, but m over 12. However, that's not one of your answers because that would be 1.075 to the m over 12. That's not one of your answers. I got 1.075 to 12 over m. I got 1.075 to that. So they've tried to trick you. Let me show you another way to write this. It's really 1.075. I'm only doing this question because I've seen it come up a couple times and I think it's annoying. 1/12 times m. And what they're really doing is they're putting this 1/12 in here. So if I come over to my calculator, I go 1.075 raised to the 1 divided by 12. See how that 1/12, I just raised that. I get this 1.00604, which is what's on the inside here. So that goes in. The only thing left over then is m. And there's your answer. Best explanation I can give you on that one, kids. The infestation of bed bugs is a huge problem in poor neighborhoods, and that is absolutely true. Mostly because you got slum landlords. You got slum landlords that don't take care of their property, so they're not taking care of the people, jerks. Anyway, scientists, not all places, lots of them are great, but not some places. Okay, scientists tested a building that was going to be demolished to determine the exact number, exactly how fast they grew. They started their experiment with only 100 bed bugs and determined that it doubled in population every 6 days. Which formula can be used to determine the number of bed bugs after n days? Now remember, we did half-lives and doublings last night, and I did it on day 1, so hopefully you understand this. All of them start with 100, so that's not a problem. They all have 100 to the 2, except for this one. This one's kind of silly. So, now what are we going to do? We need to raise it to an exponent. But this is one of those everys. Just like half-lives, it's going to half-life every 2 days. It's got a half-life of every 2 hours. This has a doubling life of every 6 days. And the every word is the most important. The denominator for your exponent will be your every word. So every 6 days, where n is the number of days. And so this is choice 1. Now let me ask you this question. When would it reach 1 million? When would I have 1 million bed bugs? So if I set this equal to 1,000,000 and I solved, could you solve that? Pause it real quick, see if you can get the right answer. Give me my kissy lips. Fish lips, whatever the hell they call those stupid things. All right, hopefully you got the divide by 100, divide by 100. So get rid of a 0, get rid of a 0. So it's really, what is that, 10,000? So 2 to the n over 6 equals 10,000. So now you got to log it. So log, it's all about the base 2 of 10,000 is equal to n over 6. Now to get rid of the 6, I multiply this side by 6, and then I multiply this side by 6. So your answer is going to be 6 times log base 2 of 10,000. Of course, you need a decimal. So 79.7 days. So in approximately 80 days, you'll have 1,000,000 bug bugs. All right, so the probability of Hilton winning a wrestling tournament is 0.85. It's actually like 0.99. But maybe not for next year. We'll see. Our guys are good. The probability of Mr. Oliveri wrestling is 0.75. If the probability of Hilton winning and Mr. Oliveri is 0.612, what can be concluded? Well, first of all, mutually exclusive means the probability of whatever the two things, the and, is equal to 0. I don't care what the two things are. The probability of the and event would be equal to 0. And here's the and event, and it doesn't equal 0, so that can't be true. Complementary events are like the probability of rain and the probability of not rain. These have nothing to do with each other, so these can't be complementary events. We can only test for independence. And remember, with an and, in this case it's what? Wrestling and Oliveri. The way we test for an and with independence is if they are independent, then the probability of the two events is equal to the product of the probability of the two events. So here's the productivity and 0.612. If these are in fact independent, I should be able to multiply these two things, these two independent probabilities, and get 0.612. So is 0.75 times 0.85 going to give me 0.612? .6375. 0.6375. Since those are not equivalent, they are not independent, which means they must be dependent. Which of the following diagrams has the greatest correlation coefficient? So you should probably draw in your line of best fit. Now the reason I didn't draw one on here is because that correlation coefficient is probably close to what I just circled, 0. So that's probably going to have the worst correlation coefficient. This one would have the next worst correlation coefficient because the points are a little bit all over the place. So it's down to these two. This one I'm going to guess is about positive 0.92. This one is really, really, really close to the line, and it would be like close to like negative 0.98999. And this one has the greatest correlation coefficient, because when you're talking about correlation coefficient, we don't care whether it's positive or negative. It's how close it is to 1 or negative 1. Since you all enjoyed recursion yesterday, I thought I'd throw you another one. Remember, a recursively defined sequence starts with a given term, and it says do something with that given term. You got to remember that when I give you a n minus 1, it really means take the second or the previous term and stick it in there. So starting with negative 4, that's a sub 1. A sub 2 is equal to negative 2 times something plus n squared. Well, notice the formula is a sub n. There's my n value. So in this case, it's 2 squared. And I'm going to put this negative 4 in here. So negative 2 times negative 4 is 8. 8 plus 4 is 12. A sub 3. What do we got to go to? 4. That's good. Negative 2 times the previous term. All recursively defined sequence use the previous term. 12 plus, in this case, n is 3 plus 3 squared. So negative 24 plus 9. That's 15, right? I hope. Up. Negative 15. So a sub 4 is equal to negative 2 times negative 15, the previous term, plus, in this case, 4 squared. So this is 30 plus 16 is 46. I don't think I should be allowed to work when I'm tired. I just went through questions 16 and 17 without hitting the record button. So I had to erase it, and here we go again. So I'm not going to be as excited. I'm not that excited about it now. Now I'm bored. I was so excited about it, now I'm bored. No, it's math. You got to be excited. Anyway, let's do this again. At least I am. You for the first time, me for the second time. Me for like the third or fourth time, actually, because I wrote the question, then I did the problem. No. Anyway, let's get started. We got an amplitude of 4. My alarm's about to go off and tell me I have to go to work. My period is equal to pi. Now that's really, really nice. I gave you the period. So as soon as I know the period, I want to go right to x scale. And we always divide by 4 because that will tell us what our goal, our scale is going to be. Because I always want the starting point and then 4 more tick marks. That's why I divide by 4. And you'll see that again when I graph. And I got a midline of y equals negative 5. So there's not really a lot going on in this problem. It just wants us to graph 2 cycles. And this piece of information you'll see is going to come in real handy in a few minutes. So since I just have to graph 2 cycles, I'm just going to start with my x-axis over here. Now since my midline is negative 5, which means the whole graph just got pushed down, I'm going to move my x-axis up so that I can make sure that I can get this graph in there. Now remember, when you're doing this on the Regents, make sure you do your graph in pencil just in case you mess up, so you can redo it. All right, let's get the scale on there. 2, negative 2. Now remember, I'm going to count by pi over 4s. 1, 2, 3, 4. When I get to this 4th one, that's when I should arrive at my period. Pi over pi. So let's see. 1 pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. And 4 pi over 4. But 4 pi over 4 is, you guessed it, pi. Alrighty. Next thing you're going to graph is the midline. And it's at negative 5. 2, 3, 4, 5. My midline. Okay. Now, the characteristic of a cosine curve is it either starts at a min, ends at a min, and has a max in between, and you draw it like this. Or it starts at a max, it ends at a max, it's got a min in between, and you graph it like this. So we have to decide. Now, this one I would use if my a was negative. Not if my a was negative, but if it was a leading coefficient, if there was a negative in the front of the equation. I wasn't even given the equation. So that's where this thing comes into play. It wants us to graph the point pi over 2, negative 1. Well, that's right here. And that's in the middle. So if it's at a max point in the middle, we're at this kind of a scenario. Max point in the middle, that means I started with a min and I ended with a min. Well, the min is down 4. 1, 2, 3, 4. So I'm going to start at a min and I'm going to end at a min. Now notice halfway in the middle is right here, and that's my max. Halfway in between those are my zeros, but there's zeros on the midline. Make sure you always go back to the midline, and then you just graph it. Make sure it looks curvy. All right. Then we're going to get 4 more tick marks, because I have to do 2 cycles. 1, 2, 3, 4. Start at a min, end at a min, max in the middle. In between the max and mins are zeros. Make sure you line up right here with this, right? You're lining up. And I graph it. That was even better the second time. Oh my God, it was so exciting. Not really. All right, let's try this one. Alarm's going to almost go off. 2 more minutes. Now let's see if I can get through. A equals 6. This is B right here. I don't like the way B was written, and you're going to see why in a second, but I'm going to write it the way it's written. 1 over 4 pi. It's always the number in front of the variable. As soon as I write B, I need to get 2 more things. I need to get period, and I need to get x scale. So my period is defined as 2 pi over B. That's why I don't like this, because it's going in the denominator. All right? So maybe it's not bad. Let's try it. 2 pi over 1/4 pi. Oh, this is actually not as bad as I thought. Don't these pi's just cancel? So when you divide by 4, you really multiply by the reciprocal. We're dividing by 1/4. We're going to multiply by the reciprocal. So that's 2 times 4 over 1, which is just 8. So my period is 8. That means it's going to finish one full sine curve in 8. My scale is always defined as period over 4, or 8 over 4, which is equal to 2. And I better get this off there. So this is 8. And my midline is y equals -3. Got to go to work, kids. Actually, I have to go to the dentist then to work. But I'm going to finish this one. So, here we go. I'm not going to finish the video because that's like another hour. Alright, use your straight edge. It's going to be on your desk so you don't make lines that look like that. Again, we moved down 3, so I'm going to put my x-axis a little bit higher. Okay, why are these people awake already sending me messages? Thank you, mister. This helped me a lot. I have the test today. Hope I pass. I hope you pass too. Okay. 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 Sorry, I don't have time to respond. Oh my gosh. You guys are awesome. I can find the slope of your head. That's great. Yes, you can use the calculator on the Regents, but you better get it clear with your teacher. Oh my gosh. How do I turn these off? Why'd they all of a sudden pop up? Now you know why I can't respond to all your messages. But I'd like to. Okay, let's get our scale on there. 2, -2. You just put the 2 there if you want. And since it's every 2, I'm just going to put a tick mark every 2. Here's 8. So when I get to 8, I better be finished with my one first sine curve. So 2, 4, 6, 8. Next thing I'm going to graph is the midline. Down here at -3. There it is. All right. So what are the characteristics of a sine curve? A sine curve starts at 0, ends at 0, 0 in the middle, and you got to decide if you're going to go up first or down first. So, and it's always on the midline, so we're going to start at 0. We're going to end at 0. It's 0 in the middle. Now, because this is positive, I'm going up first. And in between these, I'm going to go up 6. 1, 2, 3, 4, 5, 6. In between these two, I'm going to go down 6. 1, 2, 3, 4, 5, 6. And I got to do it 4 more times. 1, 2, 3, 4. Start at a 0, end at a 0, 0 in the middle, max and min. Am I recording? Because if I have to do this a third time, I'm going to be... All right, that's it. There she is. There's the equation. How'd you do? All right, I'm going to have to go to work, kids. I'll be back. You won't even notice, but I'm going to be back. I might be in different clothes by the time I get back from school. Anyway, keep studying. Hello, kiddos. I just got home from school. And my little doggy. You know what? One of my kids said, if you put your cute doggies in the video, then you get like 1 million subscribers or something like that. So here I am pandering to you dog lovers. Me, my cute little doggy. Yeah, buddy. You don't want to be here, do you? You don't want to be here. All right, you got to go. That's my little one. Maybe my big one. Maybe my big one will come to the next video. Anyway, right back upstairs. All right, let's get going. Oh my God, it was a long day at work today. I'm already home. It was like nothing, no time for you, but like 6 hours just passed. Actually, about 7 or 8, no, 9 hours. I don't know, whatever time it was this morning. I left at 6. It's now 3. That's 9 hours. Oh my gosh. Anyway, let's get started. I don't even know what I'm doing anymore. We're going to graph the tangent curve. Is that all they give us? Tangent x minus 3. All right, from negative 2 pi to 2 pi. So I'm going to put the x-axis here because the whole thing's shifting down 3 units. And the y-axis has to go right smack dab down the middle because I got to go from negative 2 pi to 2 pi. And what? Now, the thing about the tangent curve is this, is it has asymptotes. I was going to try to spell it, but I know I'm going to misspell it because I'm really tired. All right. I cannot believe how crooked this line is. That is ridiculous. But anyway, man, that's terrible. I got to fix that. Hold on. Let me see if I can try to do that better. All right, looks like I'm doing... Oh, why is it when I get to the bottom of this tablet, it causes all kinds of grief for me? Okay, there it is. There's our y, there's our x. Let me give a little scale, 1. Now, here's the thing. You have to remember that a tangent curve has asymptotes, and it has asymptotes at multiples of pi over 2. So if I just go to the right, pi over 2, and to the left, pi over 2, those are my asymptotes. So every pi over 2, so 1 pi over 2, no, every multiples, it's what it is it's every odd pi over 2. So pi over 2, and then 1, 2, 3, that would be pi. And then 1, 2, 3, that would be 3 pi over 2. And then this would be 1, 2, 3, that would be pi, negative. And then 1, 2, 3, negative 3 pi over 2. And then 1, 2, 3, that would be negative 2 pi. And then 1, 2, 3, that would be 2 pi. So I'm going to graph it from negative 2 pi to 2 pi. Now you got to remember it's got asymptotes, so we got to graph those in. And it's got asymptotes at the odd multiples of pi over 2. So it's got an asymptote here. This is going to get interesting to graph. It's got an asymptote here. And it has an asymptote here. Remember, asymptotes are not part of the graph, so in order to show something's not part of the graph, we use a dotted line. It's kind of an invisible boundary line. All right, so normally, and I'll do this what it would look like normally. Normally, I would put here, and I would just do this curve right here. And then like this. That would be normally I do, but we got a little bit of a problem. There's a midline. It moved down 3. So what I got to do is graph that midline, which is also an invisible line down here at negative 3. And because the whole graph got shifted down 3, that's where our x-axis that's where we're going to start from. That's where we're going to start this tangent curve. So the tangent curve is going to have zeros at all of these. Now, why is that? Because, remember, tangent is sine of theta over cosine of theta. What is the sine of 0? 0. That's equal to 0. What's the sine of 180 or pi? That's also equal to 0. That's why it's 0 there. What's the sine of 2 pi? 0. So that's why it's always 0. It's always 0 where sine is 0. And it's undefined where cosine is 0. Because if cosine is 0, remember that's undefined in the denominator. So quick graph looks something like this. And so I have to graph it from negative 2 pi to 2 pi. You're just going to keep this pattern going. Make sure you put arrows. Oops. And that is the tangent curve minus 3. All right, another recursive sequence. Man, I've done a bunch. You know why I've done a bunch of these? Because everybody seems to hate them. And I tried to show you a couple of different things you might see. A sub 1 equals 512. Now, in this case, they started you out with 2 terms. A sub 2 equals 256. Now, I want to point something out to you. See this a minus 1, n minus 1? And this one over here is n minus 2. Well, if you remember correctly, the a minus 1 stands for the previous term. previous term. And this a minus 2 is the one before. 1, 2 before. Before. I'll try to work on my handwriting. Oh, that's terrible. All right, so if I'm going to do a sub 3 is equal to 2 times the 1 before it, 2 times the 1 before it, plus the 1, 2 before it. And that's going to be 1024 if you put it in your calculator. So now we're just going to follow that same pattern. A sub 4 is equal to 2 times the 1 before it, which is 1024, times the 1, 2 before it, which is 256. I have no idea. 2 times 1024 plus 256. 23, well, that's weird, 2304. So all I got to do is one more time. A sub 5 is going to be equal to 2 times the 1 before it, 2304, plus the 1, 2 before it, which is 1024. So my final answer is going to be 5632. All right, moving on. Ooh, write an explicit formula for the nth term of the recursively defined sequence to below. I'm telling you right now, there's like half of you just peed yourself a little bit. You know what I'm saying? You ever seen that Peyton Manning thing when he gets so scared? He's like, "Oh, coach, I just peed my." Oh, never mind. If you don't know it, you don't know it. Anyway, recursively defined sequence. So the first thing I got to do is figure out if this is an arithmetic sequence, which means adding, or a geometric sequence, which means multiplying. I don't know why I wrote over star. Multiplying. So look what's going on here. It's taking this thing and it's multiplying by the one before it. So it's not arithmetic, it's geometric. And if you look back at the geometric formula says a sub n is equal to a sub 1 times r to the n minus 1. Okay. So that's pretty easy. I only need to know two things. 1, I need to know this, and 2, I need to know this. These are the two things I know. Well, 1's easy. There it is right there. Now I got to figure out what r is. Now r is the ratio of from one term to the next term. So it always is going to be r2 divided by r1. Now it's divided by. If you're doing arithmetic, it's r2 minus r1. Well, what is r2? r1 I know. r1 is 2x minus 4. r2 I'm not so sure about, so I'm going to go find out what r2, not 8. By the way, this shouldn't be r2. I'm sorry, kids. It should be a2. The second term divided by the first term. a1, it goes on the bottom, not r. I don't know what I was thinking of. Maybe I was thinking of Star Wars, r2-d2. Holy crap, that's hot. Anyway, so a sub 2 is equal to 1/2 x times the previous term, which is 2x minus 4. So if I put that right here, 1/2 x, 2x minus 4, oh, these just cancel. So there's my r value. There's my ratio. So 1/2 x to the n minus 1. Now, unfortunately, this is not quite correct, and I hope you saw my error when I made it. I made it a little while ago. And that is, this is a binomial. This is my first term. This whole first term gets multiplied by the ratio. So it's not good enough just to write this. You have to put this in parentheses. This whole first term times that thing. All right, this is the answer right here. Mr. Manavong invested his graduation money, albeit risky, in the Furioso Company. He purchased 50 shares of the company's stock priced at this amount. We're going to go forward 50 years, and the stock is currently worth $1,171,793. Wow, that's really good. Assuming exponential growth, approximate the growth rate to the nearest tenth of the percent. Well, if I see exponential growth, I'm going to use A of t equals P e to the RT. That's the one I'm going to use. 1171793. Check it out. Make sure you get it right. Is equal to 2500 e to the r times, in this case, 50. So what's the first step when you're solving an exponential? That's right. Get the weird thing alone. We're going to divide by 2500. I'm not even going to be worried about what this is equal to because that's fine the way it is. So now, once I have this is what I really have now. So how do I solve an exponential? In order to solve an exponential, you have to use logs. Because this is a base e, I have to use natural logs. So the natural log, base e, now you're not going to be able to put that in your calculator. And then these two things switch sides. These two things switch sides. Of 1171793, I'm just going to not put that in my calculator, right? I know I'm going to screw that up, is equal to 50 times r. Now if I just divide by 50, I'll get my interest rate. So the natural log, control E, control division, 11717 1171793 1171793 divided by 2500. I'm taking the natural log of that, and then I'm going to divide by 50, and I get 0.1229. Let me write that down. R equals 0.1229 and a bunch of nines. Now it said round to the nearest tenth of a percent. So the first thing I got to do is, don't be silly, I got to turn it into a percent by multiplying by 100. So it's 12.2999%. Round to the nearest tenth of a percent, R equals 12.3%. Alrighty, kids, let's see what we got. Not gonna let me go. Come on. All right, so I need to solve algebraically 4k in terms of w. So I need to end up with k equals something with some w's. Okay? So I need to get this thing all by itself. Now, if it's in radicals, let's get rid of it. So actually, the first thing we're going to do is divide by w to the negative 3/5. Divide by w to the negative 3/5. So what I end up with is, and this thing over here I'm going to rewrite. Remember, the 5 on the outside is my root, so I'm going to write this as k to the 4/5 is equal to, now what do you do with exponents raised to exponents? You subtract them, so it's negative 11/5 minus negative 3/5, or in other words, plus. So that ends up being negative 8 over 5. So w to the negative 8 over 5. Now I'm going to clean it up eventually. So now I still need to get rid of this 4/5. So what I'm going to do is I'm going to raise this side to the reciprocal 5/4. And I'm going to raise this side to the reciprocal 5/4. Gone, 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 gone. I end up with k equals, wow, this is the same answer I got the other day. Weird. W to the negative 2. But I can't leave it like that. That's really k equals 1 over w squared. See, notice only positive exponents. All right, there we go. Got another one. This looks familiar. So this is going to be 8x to the 3/4 power is equal to y to the 3/2 power. I need to state y in terms of x. So y's got to get all by itself. So I'm going to raise this to the reciprocal 2/3. I'm going to raise this one to the reciprocal 2/3. And I end up with 8x to the 1/2 equals y. But it's said in simplest radical form. That's weird. Why would they do that? And that's because this is the square root. So this really becomes the square root of 8x equals y, or y equals 2 square roots of 2x, right? Because this is really the square root of 4 times 2 times x. The square root of 4 is 2. So there it is, kids. There's your answer. Okay, the rise of people using VPNs to circumvent the internet policies. Okay, here we go. We got to fill in this chart right here. 55, that's 12, that's got to be 5. 87 minus 52, that's got to be 35. 43 and 45 is 88. This is 29. 75, oops. 75 minus 29, 46. Nope. 75, yeah, 46. And then 108 minus 46 minus 10 is 52. Now I'm going to check these. 52 plus 35. 52 plus 35. 87, good. 46 plus 29. 46 plus 29. And 43 plus 45. 43 plus 45. Now check the ends. 87 plus 75 plus 88, 250. 55 plus 80. 87 plus 108, 250. All right, so we know our total, 250. Woo. What is the probability a person selected at random is between 10 and 15 and uses the VPN lesson? So between 10 and 15, I'll drop this like this. 10 and 15 and uses the VPN lesson 26 times per week. That's this. So where's the overlap? The overlap's right here. So the answer is 5 out of 250. Now, what's the next part of this problem? What is the probability that a person selected at random uses a VPN over 100 times given, now as soon as I see a given, that's the only thing I'm allowed to look at. They are between the ages of 16 and 25. So they are given that they're between the ages of 16 and 25. So I can't look at that, and I can't look at that. So the only thing I can look at is that row. So what is the probability that a person at random uses the VPN over 100 times given they're between 16 and 25? 46 out of 75. Old men sit around and spew statistics about baseball players that are long since dead, although George Brett is not dead. Use the information provided to rank these 3 best hitters in history of baseball from best to worst. Justify your answer. First of all, you could just say they're all the best, because these are all the best hitters. Second of all, the only way to compare things that aren't in the same distribution is using z-scores. It is the great equalizer. So for each of these, I have to use my z-score formula, z equals x minus mu over standard deviation. So we're going to have to do 3 of these. We're going to have to do 1 for each person. So let's do Cobb, Mr. Ty Cobb. My z-score for Ty Cobb is 0.420 minus, now he was born in 1911, that's here. There's the average for 1911, 0.266 over 0.0371. So 4.15, that's good enough, 4.15. So let me grab a different color. We'll do Ted Williams. And his z-score is going to be 0.406. Now, if you first look at it, he's going to look like the best and he's going to look like the worst. But how? I don't know if that's going to be true. That's why you always have to use z-scores. Remember, it depends on what the average is and it depends on what the standard deviation is. That's why we do all this stuff. And then this was the 40, so we got to use this one. 0.267 over 0.0326. So 0.406 minus 0.267 divided by 0.0326. 0.0326. And he got 4.26. So far, he's the best. He beat him. His z-score is higher, which means you think about it. Remember, where is the z-score? The z-score is how far up above the mean we are. In this case, we're either up 4. By the way, 4 standard deviations already on the freaky end of craziness. Good. All right. So now we got one left to do. Let's do it in blue. And that is George Brett, the only one that's alive of these three. So George Brett's z-score is going to be equal to 0.390 minus 0.261 all over 0.0317. Oops. 0.261, enter, divided by 0.0317. Oops. Divided by 0.0317. And he got 4.07. So if I had to rank them, rank best to worst. Not work. That's what I'm doing right now. Worst. My best would be right here, Ted Williams. So Williams is the best. Then we got to go Cobb, because he was the next best, and then we go to Brett. And where's the justification? The justification's over here. It didn't say explain, so I don't necessarily have to read words, but I do have to use my mathematics. So hopefully you've already man, my tongue's tied. Hopefully you've already read through this problem, and you saw that it said she's going to start with this, and we're getting a 6.25% raise, and they want us to use the geometric series formula. Well, that's here in this formula sheet, right here. Where the heck is it? Right here. And the only tricky part about this formula is always R, so just be really careful about R. So S of n is equal to, the formula is the first term, which is 40,200, minus the first term, 40,200, R. Now, R is 1.0625, not just 6.25%, but 1 plus that, raised to the n all over 1 minus 1.0625. So you got to be careful. Your rate is a rate of increase. So when you do that problem, you got to do it that way. So now I just want to do it for 10 years. So I'm going to do S, the sum over 10 years is equal to 40,200 minus 40,200, 1.0625 to the 10, all over 1 minus 1.0625. Oh, am I back? I think I'm back. There we go. So we're going to put that in our calculator. Control division. 40,200 minus 40,200. 1.0625 raised to the 10 all over 1 minus 1.0625. Now that's the tricky part right there. You got to remember that. And you get $536,130 and 21 cents. Now, does that make sense? Well, if I did 40,000 times 10 years, that'd be 400,000. So it got to make sense. So write a summation expression that can be used to determine the total earnings. Well, if you're earning a 6.25%, that's an increase. That's exponential growth. So if I wanted to write the exponential growth formula, I go a sub n is equal to first term, 400. Well, it's actually a geometric sequence, but it's exponential growth. We're going to do 40,200. My rate, which is 1.0625 to the n minus 1. It's a geometric series formula. But I want to do a summation. So that means I'm going to do like this. N equals 1 to 10 of 40,200, 1.0625 to to the n minus 1. So we're going to practice this. Now, if we get it right, we should get the exact same answer as we did the other way. So we'll go into summation. Oops. Summation. N equals 1, 10, 40,200, parenthesis. Don't use the parenthesis they give you. And we're going to raise it to the n. And we should get the same number. We don't. What did I do wrong? All right, kids, I found it. Did you find it? Did you see it? Go back over here. It's n minus 1. It's not to the n. It's to the n minus 1. Common mistake. Dumb brain fart. There we go. $536,130.21. There it is. Same number, same answer. All right, done with that one. In order to fumigate a house, companies must use methyl bromide, which, if ingested in the body, has a half-life of 12 days. Uh-oh. That sounds like it might be mixing units. 12 days. This is why they tell people they can't re-enter the house for 3 days, following fumigation. Of course, Miss Cavoots thinks she's a rebel, and she doesn't want to wait too long, and somehow she determined that she invested 200 milliliters. Now, I'm not even sure if that's possible, but let's go with it. So she ingested 200 milliliters. Write a formula that can be used to determine the amount of methyl bromide in the hour in the body after H hours. Did you see that? That is a huge problem. Days, hours. Don't be victim to mixed units. So, half-life, the amount of bromide over H hours is equal to 200. It's a half-life, so half. And the denominator goes, remember, goes the given, right? So in this case, it's given 12 days, but 12 days, oh my goodness. Yeah, 12 days, a lot of hours. So we got to do hours. Oops, that's not what I want. So 12 times 24. 12 times 24. 288 hours. And H. So, how much bromide is in there after 48 hours? Okay, A sub H is equal to 200, half-life, 1/2, 48 over 288. 200, parentheses, 0.5, that's the same as a half, raised to the 48 divided by 288. Boom. 178, what do we say, rounded to the nearest tenth? 178.2. Once the amount of methyl bromide falls below 10 milliliters, it is no longer considered dangerous. So that means our final amount is going to be 10. Our beginning amount is 200. 1 over 1/2 H over 288. All right, so now we got to solve, so you get the weird thing alone. So we're going to divide by 200. So that's just 1/20th. So now that I have an exponential here, in order to solve an exponential, you got to use logs. Log, it's all about that base, about that base, about that base, all about that base. There's the base. So log base 1/2. And then these two things switch side of 1/20th is equal to H over 288 hours. Well, how do I get rid of that 288? Yes, that's right. You multiply both sides by 288. So 288 times the log of 0.5, it was 1/2, right? Of 1 divided by 20. 1,244 hours. So H equals 1,244 hours, 0.715. You'll see why I'm doing this. 29133. 29133. But that's not what it asked. It said to the nearest day. This is hours. So now we got to switch back to days. Doggone it. Now I got to go back and divide by 24. So 51.8 days. So 51.8 days, which is approximately 52 days. And that's the answer, 52 days. Tough problem. I love that problem. All right, focus directrix, kids. Let me take a pause. I'll be right back. Man, kids. I'm going to do this one two ways. I don't remember what gets turned off in your calculator. So in test prep mode or in test mode, I don't remember. So we're going to do this two ways anyway. We're going to do the easy way, the harder way, and then the really hard way. So 4. This is going to be the easy way. So this gives me y plus 3 is equal to 1/4 x minus 6 squared. I'm going to bring the 3 over. So y equals 1/4 x minus 6 squared minus 3. Now the reason I do this is because now it's in vertex form. It says my directrix is y equals -4. 1, 2, 3, 4. My vertex is 6, -3. 1, 2, 3, 4, 5, 6. 1, 2, 3. So if you remember correctly, in a focus directrix formula, or in focus directrix, if this is the directrix and this is the focus, the vertex is right in the middle. That's your vertex, that's your focus, there's your directrix. So that means that my focus should be right here at 6, -2. Now, I don't know if they're going to restrict the use of this. I don't remember correctly. I got to look into it. But you can always graph this. Try to graph this. Control division 1/4 x minus 6. X minus 6. I want to think they do restrict this, but I'm not sure. -3. Press enter. There it is. All right, so then go into menu, analyze graph, analyze conics, focus. Click. Now there it is, 6, -2. Shoot. 6, -2. But I want to make sure I have the right directrix too. I should have a directrix of -4, and there's -4. So there it is. That's one way to do it. Let me show you another way to do it. Another way to do it is probably the way you tried to tackle it at first. Distribute the 4, so you get 4y plus 12 equals, and double distribute this out, you get x squared minus 12x plus 36. Bring the 12 over, you get 4y equals x squared minus 12x plus 24. Divide by 4. So I get y equals 1/4 x squared minus 12x plus 24. Now one thing, oops, no. Minus 3x. You're dividing by 4, dividing by 4, dividing by 4. Minus 3x plus 6. Now, they can't stop you from doing this. We'll come over here, and you go to your graphing calculator. We're going to graph that. Tab. 1/4 x squared minus 3x plus 6. They can't stop you from graphing that. Now, let's say that you can't do that. Let's say that focus. You know what? Let me just do it this way. I want to make sure you have a fresh graph so you see what's going on. So 0.25x. That's the same as 1/4 x squared minus 3x plus 6. There it is. All right. So let's say that's our graph. So let's say we're not able to use the focus directrix, but what I can do is menu, analyze graph. Minimum, click. It will tell me that the minimum is 6, -3. I can draw a quick sketch over here. If I have a directrix of y equals -4, I plot the point 6, -3, and the focus is just above it at 6, -2. But anyway, there's the answer. Here's another way to ask a focused directrix question. It says derive the equation of the parabola with the focus of that and the directrix of that. So if you remember correctly, wherever the focus, the directrix is, and the focus is, the parabola goes anywhere in between. And any point on that parabola is equal distance from the focus and from the directrix. That is the idea of a focused directrix. So I have to use my distance formula. My distance from my given point, which I'm going to call xy. So my distance is equal to y minus the directrix, because this vertical distance is just y minus whatever that is, so y minus 6. And the other distance is equal to this point to that point. So that's going to be the distance formula. X minus 5 squared plus y minus 1 squared. Now, since these two distances have to be the same, I'm just going to set these two distances equal to each other. Y minus 6 is equal to the square root of x minus 5 squared plus y minus 1 squared. All right, in order to get rid of a square or a square root, I square both sides. On this side, over here, I'm going to get y squared minus 12y plus 36 is equal to x squared minus 10x plus 25 plus y squared plus, oops, that's minus. Be careful. Be really careful with your double distributing over here. This is really y minus 1 twice. So minus 2y plus 1. If you do it correctly, the y squareds cancel. Now we're going to bring all the y's to one side, so I'm going to add this 2y over. And I get negative 10y. And I'm going to subtract this 36 over. Is equal to, oops, sorry kids, the y squareds canceled, not the x squareds. This y squared canceled with this y squared here. All right, is equal to x squared minus 10x. Let's see, 25. And 1 is 26, minus 36 is negative 10. Almost done. We're going to divide by negative 10. Oh, not again. Here we go again. Please don't lose this. Okay, kids, I'm going to try to hurry up through this. I disconnected, oh, come on. I disconnected a few things, so let's hope it works. I'm almost done with this problem. We're just going to divide by negative 10. Divide by negative 10, divide by negative 10. I don't even know where I was with this problem. So what it looks like I get is y equals negative 1/10 x squared plus x plus 1. I'm just going to check that real quick to see if I'm right. I did. Hopefully everything, oh, I can't use my mouse anymore. So I got to use this. Let's see if that's even going to let me. All right, so 1/10 negative 0.1 x squared plus x plus 1. There it is, and go menu, analyze graph, analyze conics, and directrix. Click on this. My directrix is 6. That's what I expected it to be, right? Isn't that what I expected it to be? And I need a 5-1 as my focus. So menu, escape 6, 9, focus is 3. Click on that, and there. Oh, geez, it was right. Control Z. Click on that. It's 5-1. There it is. Well, there it is, 5-1. All right, I get off that problem. Holy crap. Hopefully this will work. All right, so look, take a look at this one. I want to solve for h and k, and I don't know if you noticed or not, but we got an h here. We got a k here. So we got to solve for those. So the first thing I'm going to do is just distribute to get rid of these parentheses. So 6x cubed minus 19x squared plus 3x plus 21 is equal to, now I'm going to distribute this to all three over there, right? So 6x cubed minus 2hx squared minus 12x. Now I'm going to distribute all these. Minus 3 times 3 is 9, minus 9x squared, minus 3hx plus 18 plus k. So the hard part about this problem for most kids was, first of all, these can go because they're both the same on the same time. The hard part about this one is just understanding what's going on. It looks like I have 19x squareds here. So wouldn't I need 19x squared here? So my negative 19x squared should equal negative 2hx squared minus 9x squared. Bring the 9x squared over, I get negative 10x squared equals negative 2hx squared. Divide both sides by negative 2x squared, divided by negative 2x squared, and I get h equals, it looks like h equals 5. h equals 5. Now these are the constants, 18 plus k, so 18 plus k must equal the constant on this side, 21. So it looks like k equals 3. Now there's a nice quick test for that. Come over here. Don't save. Go back into graph mode. And we're going to graph the left side, 6x cubed. 6x cubed. Because I don't know if I'm right. Minus 19x squared. Minus 19x squared. Plus 3x. Plus 21. And we'll graph it. It'll look weird. There it is, looking weird. Now graph the right side. I got to graph the right side exactly as it started. So press tab, parenthesis, 2x minus 3, parenthesis, 3x squared, plus, and h was 5, so 5x, minus 6, and then outside the parentheses, plus 3. Now, if it's right, they should match right on top of each other. So watch the blue curve. If this is right, it should go right on top of it. It's not. So I did one of two things wrong. I didn't type it in correctly or I didn't solve it correctly, but it's a great test. I had no idea if I was right. So let me make sure I type these in correctly. 6x cubed minus 19x squared plus 3x plus 21. So that appears to be right. Make sure I get this one in right. Oh, here's my problem. 2x times hx squared is just positive 2x. So this should be positive, which would actually make this negative. So let's see if that fixes things. We'll press tab, hit the up arrow, and it should be negative 5. Notice how it matches right over it, tab. That was a quick fix. But I knew I did something wrong. See how it's right on top of it? I knew I did something wrong when it didn't come out to be right on top of it, so now I was able to fix it, and it was right there, and I did not do that on purpose. So I'm glad I checked my answer. Algebraically determine all the zeros of this root. Well, there's no way to find the zeros of this thing until I actually find out whatever this thing is. So I'm going to use this information right here to find that by plugging it in. So in for p of x goes negative 64, and in for x goes negative 4. So 6 negative 4 to the 4th plus b times negative 4 cubed plus 21 times negative 4 squared minus 108 times negative 4. Now all of that stuff gets put in my calculator. So 6 parenthesis, you know what? This is how I'm going to do it. Negative 4, control var x. Let's enter. And so it's going to be 6x cubed, 6x to the 4th, 6x raised to the 4th. Now I'm going to skip the cube term because I don't know what b is. So plus 21 parentheses, 21x squared minus 108x, minus 108x. Press enter. 2304. So negative 64, that doesn't appear right, but let's just check it out. Negative 4 cubed is negative 64. So this is negative 64 times b plus 2304. So we're going to subtract this over. Negative 64 minus the answer is negative 2368 is equal to negative 64b, doesn't appear to be right, divided by negative 64, and we get 37. Okay, it is right. So b equals 37. I knew it was going to be right. So now what I have is this. I have this quadratic 6x to the fourth plus 37x cubed plus 21x squared minus 108x. Now before I do anything, I want to find the answers. So I'm going to use my features of my calculator I can do, and I'm going to get my calculator to factor this thing for me. So menu, algebra, polytools, find the roots of a polynomial. Now this is a fourth degree polynomial. So notice that has 5 boxes. 637, 21, negative 108, and make sure I put that negative in. And the last one is 0. There is no constant term. So I just click OK, and I press enter. And those are my answers. Weird. All right, so it looks like my answers are going to be negative 9 over 2, negative 3, 0, and 4/3. Well, it should come as no surprise that negative 3 is an answer. There it is right there. It should come as no surprise that 0 is an answer because I can factor out a 0. X times 6x cubed plus 37x squared plus 21x minus 108. All right. So now I'm going to use this feature right here. If negative 3 is a root, then x plus 3 is a factor. And I'm going to use long division to divide this sucker. So x plus 3 into 6x cubed plus 37x squared plus 21x minus 108. Now when I do this, I better have 0 at the end. Otherwise, I made a big mistake. So let's go. 6x squared. And 6x times 3 is 18x squared. Don't forget we're subtracting. Subtract. So 37 minus 18. Brain's a little tired. 19, of course. 19x squared plus 21x. So now I'm going to do multiply by 19x. So 19x squared plus 57x. Subtract. 21 minus 57. Negative 36. So I get negative 36x minus 108. Remember, if it doesn't turn out to be 0, you made a mistake. Negative 36. Negative 36x minus 108. If I multiply the negative 36 times 3, subtract, and I get 0. Good. All right, good. So the only thing I left to do then, if I want to find the roots, is to factor that sucker. So 6x squared plus 19x minus 36. 3x and 2x. Now the beautiful thing is I already know the answers. Negative 9 halves and 4/3. X equals negative 9 halves and x equals 4/3. Well, the 3 is already there, so minus 4. The 2 is already there, so plus 9. Let's make sure this makes sense. 27 minus 8. 19. Perfect. There's my answers. And I'm done. Wow, that was a pain. All right. All righty, kids. We're getting close to the end. All right. Anytime you want to solve a radical equation, you need to get the radical by itself. So we're going to subtract this 7x. I end up with x squared minus 4x plus 4, equals negative 4x minus 7. Man, that's going to be a pain in the neck. Anytime you have a negative, you got a pain in the neck problem. Square this side and square this side. Let me do this. Negative 4x minus 7. Negative 4x minus 7 over here. So this is 16x squared plus 28x plus 28x is plus 56x plus 49. That's really weird. So x squared minus 4x plus 4 equals 16x squared plus 56x plus 49. Now, because it's a quadratic, you want to set it equal to 0. We're going to move everything to the right side and get 0 over here. So subtracting x squared, I get 15x squared. Subtracting or adding 4, I'm going to get plus 60x. And subtracting 4, I get plus 45. Now, the cool thing is there's a big GCF that comes out of this. 0 equals 15x squared plus 4x plus 3. If I factor, I get 0 equals 15, x plus 1, x plus 3. So my two answers are going to be x equals negative 1 and x equals negative 3. Now, check both. If they both don't work, you done something wrong. If they both work, that's really rare. Usually one doesn't work. And don't forget, you got to check them back up here in the original. Don't check them in the changed equation. So, first things first, we're going to store negative 1. Negative 1 control var x. Press enter. And we're going to type in the left side exactly as it appears. Control square root x squared minus 4x plus 4 minus 4x plus 4 outside plus 7x. So I get negative 4, but now I got to type the right side in, 3x minus 7, 3x minus 7, negative 10. Oh, that one doesn't work. Let's try the other one. Negative 3, control var x, enter. Now I'm going to go up here. There's the left side. I don't have to retype it. Negative 16, negative 16. So, make your answer look sharp. Use some nice curly brackets. The answer is negative 3 only. All right, almost every single time you do a radical equation, one of them is going to die, okay? So make sure. So we're going to bring this 4x over. So now I get the square root of 4x squared minus 8x plus 20 is equal to 6x minus 2. We're going to square both sides. This one's not as hard as the last one. I don't think. So it's 36x squared minus 12x is minus 24x plus 4. Bring everything to the right side, so 0 equals 32x squared minus 16x minus 16. All right, now the beauty of that is I can take out an 8. Actually, I can take out a 16. That's even better. 0 equals 16. 2x squared minus x minus 1. That's what I got to factor. So this is going to give us a solution. 2x and x minus 1 and plus 1. Those are the answers. So x equals negative 1/2 and x equals 1. So we got to do the same thing. We got to check it. There's no shortcut for checking. So 1 store x. 1 control var x. Now I got to type it in. 4x squared minus 8x. 4x squared minus 8x plus 20 minus 4x equals. Now the right side I'm going to have 2x minus 2. 2x minus 2. Hopefully it's 0. Hey, it's 0. 1 works. Now I got to check the other one. What's the other one? Negative a half. So negative 1 divided by 2, control var x. Press enter. Hit the up arrow. There's the left side. There's the right side. Oh, so the only answer is 1. I think we only got three questions left. I can blow through these. I can blow through at least this one pretty quickly. This is an exponential question. In order to solve, or excuse me, this is a logarithmic question. In order to solve a logarithmic question, you need to turn it into an exponential. And it's all about that base, about that base, about that base. There's the base right there. So it still is my base, x minus 8. These two things switch sides. So x minus 8 cubed is equal to 27. Well, how do I get rid of a cube? You raise it to the reciprocal. And I get x minus 8 equals 3 or x equals 11. And if you checked it, it'd work. All right, let's do this one. It's all about that base. The base is x minus 2, and then these things switch sides. So x minus 2 squared is equal to 3x squared minus 17x plus 25. Double distribute the left side. X squared minus 4x plus 4 equals 3x squared minus 17x plus 25. It's a quadratic, so everything has to go to the right. 0 is equal to 2x squared minus 13x plus 21. Got to factor that sucker. 0 equals 2x and x. They both got to be negative. This is going to be 7 and 1 probably. Is that right? No, 7 and 3. No, that's not backwards. That's backwards. This has to be 3, and this has to be 7. Negative 6 and negative 7 make negative 13. You can always use menu 3 through 1. Your two answers are x equals 7 over 2 and x equals 3. Logarithms should be checked. Logs should be checked. So I'm going to go back and check this one first. So all logs should be checked. I didn't do it because I know this one. I'm pretty sure this one works out. 11 control var x. Shut up. 11 control var x. And then I'm going to type in control log x minus 8 of oh my goodness. Everything's going to heck on me. X minus 8 of 27. There it is, 3. Perfect. Okay, that one worked. So now we're going to store 3, control var x, enter. And now we're going to type this one in. Now remember, we're going to type in the left side, and we're hoping it turns out to be 2. So log, control log, x minus 2 of 3x squared, 3x squared minus 17x plus 25. And we want it to be 2. That's not good. All right, let's try the other one. 7 divided by 2, control var x. We want it to be 2. There we go. There's always one that fails, and it's kind of disconcerting because you're like, I know I got it right to do it, but check them both. If they both fail, you probably did something wrong. All right, kiddies, we got to hurry. My dogs are up there, and they want to eat. All right, Mr. Roloff and Mr. Dupre have both become mad chemists in their old age. Both of these men have created the new Get Muscular Quick formulas, both of which think that their formulas are the best. So they've decided to test it on the first 20 willing members of the Weird Gym. The 20 willing members were randomly selected into 2 groups, but not told which group they were assigned. Only the owner, Grace for Weird, knew. The members' muscle mass was measured by Dr. Pastilli and recorded before and after the trial. Their percent increases are below. So it looks as if Roloff was better than Dupre. So Louis Dupre had been using the Dupre formula all year and is adamant that the Dupre formula is better. Using the information from above and the experimental design, explain why Louis may in fact be correct, even though they're lower. So there's a couple things going on. First of all, it could be due to a low sample size. So something like this. I'm going to try to be neat. Even though the data shows that the roll-off drug, I guess, has bigger gains, it could be due to sampling variability. In other words, should I write this? I'm trying to think. Which really means that, Roloff could have gotten the ones that were just destined to get bigger. So that's what that part means. The other problem is the sample size is too small. Which means it is subject to larger swings. Or in other words, larger standard deviations. Therefore, Louis may actually be correct. Woo! All right. So, what they decided to do is take the groups, redistribute them, mix them all up into two groups of 10, and do it 800 times. Once they realized, once Louis saw this distribution below, and brother Sammy explained statistics to him, he realized that the difference this large in percent increases is quite an unusual occurrence. Would you support this statement? Justify your answer. So first of all, notice that these differences are Dupre's minus Roloff. So Dupre minus Roloff in our sample was 3.10 minus 3.25 or negative 0.15. So should we see negative 1.5, negative 0.15 a lot or only a few times? Well, let's see what we got here. That's like 10. We'll go with 12 just to make it bigger. That's 8. And 5. That's 20, 25, 20, 30, 1, 2, 3. About 33. 33 out of the 800. 33 out of the 800. I don't even think it's 33. Maybe 33. 33 out of the 800 would see this big of a swing or bigger. So is that common? I don't know. Let's see. 33 divided by 800. 0.04125. Now taking the bigger numbers, this is as big as I can go. I got 0.04125. So in other words, this big of a swing or less is going to happen less than 5% of the time. So he realized that the difference this large in percent increases is quite an unusual occurrence. So in other words, should this happen regularly? Do you support this statement? I don't really like that question. I could probably ask that one. So, yes, differences this large based on the distribution above is quite unusual. Which means, let me see, quite unusual. In fact, we would expect to see differences this big or bigger in only approximately 4% of trials. Since not size, since this is an unusual occurrence, it could not have happened well, I don't know if I should say could not have happened. It is unlikely it is unlikely to have happened by chance. Therefore, the roll-off drug is probably more effective. Let me try to explain that without the words. So we tried it. We came up with a difference of negative 1.5, which looks like it's a huge difference. It actually looks like a really tiny difference to us. But when we come down over here, we should only expect to see that in 4% of the models. So all of this, it's in the tail, and anything way in tail is unusual. All this stuff in the middle here, all of this stuff here in the middle, we expect this to happen. But things that are way in the tail, we don't expect to happen. So if we don't expect it to happen, then it really shouldn't happen by just chance. Therefore, there has to be something else that's causing such a large difference. And the only thing that could be causing such a large difference in this particular case is that the roll-off drug is better than the Dupre drug. Now, in effect, the trial size is so small, probably not. But based on the given data that we have in this thing, that's the best explanation that we can come up with. I hope you got it. I hope you understand it. I got day 3 coming tomorrow. Day 3 shorter, and I think that's all I'm going to get time for. I'm only going to have time for day 3. And actually, quite honestly, in my review sessions, all 3 of those days are going to stretch out over 4 days. Keep studying, study the flashcards, keep working, hit the subscribe button. Good luck on the Regents, kids. And remember, I can't post anything until June 30th. So that's the best I can do. Catch you all on the flip side. Goodbye. Goodbye.